Alright, hello everyone. As Afaf introduced, my name is Kaan. I'm working at the Ethereum Foundation on the project called Sourcify. And today I'll be mostly speaking, I've been half and half. I'll be speaking about Sourcify and mainly the Verifier Alliance. It is the brand new thing we found recently. We haven't been talking about it that much, so now we are starting to talk about it more and more. Yeah, I'm also so glad I'm back in a crypto meetup. I was in a corporate meetup last week in Deutsche Bank BTC. No, it's not Bitcoin, Berlin Technology Center. And yeah, it's a typical corporate meetup, innovation, technology. And I found out in Deutsche Bank's Technology Center there are 1,300 people working. Like, what are you doing with 1,300 people? It's almost the number of developers in our ecosystem. So yeah, anyways, it's good to be talking to people of our kind, let's say. Where's my mouse? Right, so Sourcify. Before I begin, maybe a couple of questions. Who knows what a smart contract is? Great. Very small group, so don't be shy. Who has ever looked at a contract source code on Etherscan? Cool. Who has ever verified a contract on Etherscan? Nice. And who knows what Sourcify is? Okay, not bad. Thanks. Sourcify is a decentralized and open source smart contract verification service in short terms. But if you ever listen to my talks before or another Francis talks or maybe even our websites, I confused the ordering. So we are three people. I'm Kaan, another recent team member is Manuel, and we have Marco from Italy. We have three people building this. Yeah, but as I said, if you were to listen to my other talks or look at our websites, you will see many other things. You'll see solidity metadata, you'll see human-friendly contract interactions, you'll see NatSpec, ITFS, whatever, all these things. But these were also our goals in the recent years. But recently we are more focusing on one thing, and that is this decentralized and open source smart contract verification. But what exactly we mean by this, if we focus on the two value propositions, let's say we have, being decentralized and open source, comes from an assumption that something is centralized and something is closed source, right? And this is the current de facto standard in the ecosystem. Yeah, currently it's not decentralized or open source, and we are talking about these guys, Etherscan. So now I don't want to throw fingers at anyone. Like when I talk about stuff, it is as if like I'm a Etherscan enemy or something. Of course, like they bring a lot of value to the ecosystem, and I know the Etherscan guys, they are really cool people. But at the end of the day, where we end up is not perfectly aligned with our values. Like we don't want to have contracts, all the Ethereum contracts owned by a single entity. If it goes down, everything stops. Like most of the consumers won't be able to get to know what's happening on the chain. And beyond its values, it has a lot of risks. As I said, when it goes down, it goes down. If it's lost, the contracts are lost. One thing I keep bringing up, and that bothers me, is when the Rinkeby and Robston testnets were shut down or they're deprecated, they were gone with their Etherscan instances. So You can say, like, so what, like they were testnets. Yes, but that means also part of the whole knowledge in the internet about Ethereum is also gone. When I go to a forum, click a link on Robston Rinkubi, it's not there anymore, so I don't have the context, I don't know what's going on, so they were gone. This partly or actually has happened. And also you have to, if you're a chain and you want an Etherscan instance, you have to pay millions to run an Etherscan instance, which, yeah, is quite much money. Before we dive, let's recap a bit what smart contract verification is, what we are actually talking about in the technical terms, not going too much into detail. In short, smart contract verification exists because the contracts on blockchain or any chain lives as bytecodes, like here. And this is what you see when you look at a code and when you look at a contract if you don't verify it. And we humans cannot read the bytecode. We don't understand it. It's for machines, and we can't make sense of it. What we want is something readable, at least in human language, in Solidity, in Viper, or in any other language. But what if I come to you and show you this code on GitHub and claim that this is the code of a contract? Like, how do you know this is actually this contract that is powering this contract? At the end of the day, you are giving your money to this piece of program, and how do you know? How can you make sure this is actually what it's doing, and not that it's stealing your money? What we have right now is this thing. This is how we see on Etherscan. As I said, it's the most popular block explorer and the contract verifier. And what we want is actually this green check mark. You see green check mark, you see source code, you're happy. And in technical terms, this is how it works. So we have the contract files. Let's say we have 3 files, then we have some compiler settings. Then we feed these into a compiler. In this case, Solidity compiler. This could be Viper, VerA, Huff, other languages as well. Then this gives us a bytecode of the contract. Then we take this bytecode from what we get from the user when they give us the source code. And the user wants to verify a contract on a blockchain, let's say at this address. And from the chain, we get the on-chain bytecode, and then we compare it with the compiled one. If it's a match, we say, okay, the source code of this contract at this address are these ones. Let's say my contract ownable ERC. These are the Solidity files, Solidity contracts that make this contract. So this is how it looks in technical terms. And how does Sourcify solve the decentralization and the open source issue? So mainly the obvious one is we are open source. So this means anyone can run their own Sourcify. Indeed, people do. In the next slide, I'll show about this. And yeah, you can see how the Sourcify works and how our verification works. That's the main thing. And we want open source code. That's another thing. And indeed, as I said, people run their own Sourcifys. For example, Hashscan is the Hedera chain's main block explorer. If you're familiar with Hedera chain, it's another EVM chain. And their block explorer is, for example, powered by Sourcify right now. They had their own Sourcify fork. And in the next weeks, hopefully, we will start using one single source. Like they originally forked it, but in the next weeks, we will start using one instance customized for their own needs, ours customized for our own needs. That's one thing. So anyone can their own Sourcify. And it's decentralized in the sense that all the data is public and available and also available on IPFS. So there are other features that we use for IPFS, so I don't want to get too much in detail about that. But at the end of the day, it's not really easy or possible to download all contracts from Etherscan or another block explorer, but in our case it's possible to dump and download everything and do whatever you want with all these contracts. Right now we support 144 EVM chains. These include the main chains that we know, Ethereum, Optimism, the popular ones, to the ones that you've never heard of. So we are also kind of helping out those chains, or let's say we try to capture those people and onboard them to Sourcify before they're gone. And you can verify the contracts through the Sourcify UI, the API, or you can also import from Etherscan. You can verify contracts through Hardhat. So we have Hardhat verify support now that with the Hardhat verify command you can also enable Sourcify, and with the same verification command you can also verify your contract on Sourcify with Hardhat. Is there a question? Okay. You can also verify with Foundry. Similarly, Foundry's verification module also supports Sourcify. You can pass the contract address, chain ID, and also even provide a custom Sourcify instance to verify your contract. And lastly, you can verify your contract on Remix Sourcify plugin. Right now, this is only for Sourcify, so it has a separate module than Etherscan. You can also see its view, coincidentally. But what we are working towards is having more parallel verification between different verifiers. So what we want actually is not to have separate modules for each verifier, Etherscan, Sourcify, BlockScout, you name it. But we want to have a single verification module, and then users being able to parallelly verify everywhere. So all the workload should be handled by the plugin, and as a user you should just click verify and it should go everywhere, because we don't want a contract to be at a single place, ideally, unless you opt out. So this is what we are building next for Remix, and we also are trying to push Hardhat and Foundry in this direction to allow parallel verification. But we do our best, but this is a big problem, and we can't really solve this by ourselves as Sourcify. So we have so many resources. It is difficult to push developers in one direction and to change their habits. It's also difficult to talk to tooling, change their habits, even though everyone's quite welcome, but when it comes to action, it falls short. So we can't do it by ourselves. The mission of, let's say, decentralized and open source verification, easy and unified access to contracts. So for that, we recently formed something called Verifier Alliance with the familiar people from the ecosystem. This happened last summer, I think, in the ECC, in a rather random encounter with these people. And once we started talking, there comes the idea, actually led by Sam Cizon, if you know him, actually led by them, to have something like an alliance between us to share data and push the whole ecosystem in this direction. That's what I want. That's what I find the conferences valuable. Such encounters don't happen everywhere. And we founded this alliance recently, and we are now working towards this. In short, the alliance is an ecosystem collective for easy, unified, and open access to the source code of EVM source contracts. So not only Ethereum ecosystem, but all the EVM smart contracts. Also not limited to Solidity only. We also have Viper in different verifiers, or maybe in the future, the other EVM languages. And it's actually quite simple. It's not rocket science what we are doing in the surface, let's say, but behind the scenes there are a lot of coordination work that has to go on and a lot of things to align between all the stakeholders. But yeah, the idea is quite simple. The idea is like, what if took all the contracts and put somewhere? This is, in one sense, it's really simple. In short, we just take everything from everyone and put it in a database. That's it. So, but I mean, it's simple, but it hasn't happened so far. But that's what we are trying to do now. If I explain a bit the idea, so what would happen if you want to use Verifier Alliance, or if you want your contract to be on the Verifier Alliance database, is you go one of the verifiers or data providers here for now, and you verify your contract there, and at the end, your contract will end up in the database. Yeah, the database has a schema, a specific schema for our needs. You can find out the schema spec here. It's an SQL database. The diagram looks like this. So in general, we have partitioned the different parts of the contract in different tables. Let's say, in general, we have the difference of compiled contracts and the deployments. So we don't have a single row or single table of everything together. In this case, we have the code separate from the compilation and the compilation separate from deployments, and a verification essentially is a linking of a compilation and a deployment. So this allows us to deduplicate most of the contracts, as well as being able to play around with other things, such as looking at the code, trying to find contracts that are similar to this code, etc. So right now this serves our needs, but over the time, as the use cases probably will develop, and we will see if this is a fitting schema or not. Yeah, as I said, we decouple the compilations from deployments. We also have a separation between the runtime and creation code match. So runtime code is, if you're not familiar, runtime code is the actual code that is running of your contract, and creation code is the code that is executed when you're creating the contract. So it's executed once, then it turns into a runtime code. And we have matches for both cases. So you can have, you have a creation match, you have a runtime match, and transformations. We also have the concept called transformations. So when we are verifying a bytecode, we have to leave out some of the fields from the bytecode that are, let's say, deployment specific or contract specific, but is not affected by the compilation. These are library addresses, link libraries, immutables, and the CVER aux data, if you know what it is, maybe you've heard of it as the metadata hash as well. So these parts don't directly influence the function of the contract, let's say. So that means before verifying a contract, we leave out these and we put them in a transformation. So one example is this one. I think this is a creation code transformation. Yeah, that's a creation code because it has a constructor transformation. In this case, we say, okay, when this contract was being verified, the aux data is replaced with this one, and these constructor arguments were inserted at the end of the contract. So next time when we are verifying the same contract, if maybe with different constructor arguments, we can take the all existing things and then just throw a different constructor argument and call it a match really easily. And in case of a runtime match, for example, we have a library linking here. The first one is a library this is a placeholder in the bytecode, and then this placeholder is replaced by this address. This is the library that is being used as the this is the on-chain address of the contract, and then again the CVER aux data transformation and the immutable transformation. Immutable values are the variables that are put inside bytecode, which the name suggests they are immutable once they're deployed. So yeah, right now I just checked, we have around 605,000 contracts, 650,000 contracts, and it's growing. I mean, it's a big number, but it's compared to the all existing contracts, it's not that big right now because we are syncing with each other, but we don't have the historical contracts. So we have to, at some point, all the data providers need to go back and get all the historical data to the database. But also the Alliance is not only a database. So yes, the main artifact is database. It is the main outcome. It's simple, but it's also a knowledge base for everything about verification. Right now, both the code is closed source and the knowledge is closed source, and we're hoping this to change with this Alliance and in general push the whole ecosystem in this direction. Yeah, and on top of that, there might be tooling built because this effectively becomes a standard to represent verified contracts. And taking this standard, people can start building the standard toolings on top of that. For example, you can build tools that let you verify locally the contracts really easily without trusting anyone else. And yeah, as I mentioned, you can do, for example, bytecode similarity search. So if you have a bytecode that is not verified, you can do certain similarity search on top of that and see, okay, this contract can be this, it's similar to this, I don't know what. So once we give the dataset to people, I'm quite sure there will be a lot of interesting applications that we haven't heard about it. But it's really a pity right now, the dataset is not there, so no one's working on the verified contract dataset. Talking about the dataset, we are planning to share this regularly in Parquet format, dumps, database dumps, maybe daily or on another basis. And we are thinking about maybe giving an API or application access so that, for example, the contracts you are seeing on your Block Explorer will come from this database. But this is just an ideation phase right now, so because the public API, app is a, let's say, different endeavor. Yeah. So yeah, that's it from my side. You can go to the verifieralliance.org. This is our website to have more info. Follow us on Twitter. We also have a public Telegram chat if you're interested about contributing or even about the datasets. Right now, as I said, it's not open, but if you want to play around, we are slowly giving out read access to people. Also, if you're interested in Sourcify, these are our contacts. So yeah, thanks for listening. Are there any questions? Yes, please.
So this Verifier Alliance, what's the incentive for the people or the companies that are running the verifiers? Is there any incentive or just like public goods?
You mean the participants of the Alliance, right? Yeah, so for us, for example, this is our mission. Like the Sourcify is a public good, we are not a company, but we are working towards this, so this perfectly aligns with what we want. But if you think about other block explorers, Block Scout, Dora, Route Scan, etc., so they are kind of fighting a monopoly, right? The Etherscan as the monopoly, and they also, of course, want this monopoly to be broken. And at least on the verification side, the Block Explorer has really network effects anyways, but at least the verification side of things will be broken. So they are, of course, incentivized to participate in. So this is like, we are trying to pull them in this direction. Maybe if this wasn't there, they wouldn't be incentivized to share their data, share their contract data, but if enough people share it, we hope to push the whole ecosystem and maybe Etherscan themselves to open up as well. Yes, sure.
So you said that on top of this, so you selected all these smart contracts, 650,000, and on top of that, maybe later on you could like create APIs or some tooling. So that means that any person or the app developer, they can like, for example, I'm just thinking out loud, maybe they provide a parameter that has all ERC20 token contracts, let's say, and they get it. What kind of use cases do you think just for enable? Like, what other than for analysis or statistical purposes, what other use cases do you have in mind for us?
Yeah, the immediate thing, for example, I have in mind, and this was also discussed, is when there's an vulnerability, for example, and if you have such a data set, you can just go to the data set and see where this vulnerability is in which contract. Like it's just would be a simple search, and if you want to extend your search, you can even search more things. Like this is, for example, one immediate case.
Yeah, that's a good one.
Other questions? Yes, please.
What do you do differently than Etherscan? So for the developer, where is the use piece from the UX kind of perspective?
Mm-hmm. Yeah, the UX part is the most difficult part, I would say, because all the users are accustomed to the Etherscan verification. Now I'm talking more about Sourcify. And what we also do differently is we support something called full verification, which means we verify both, I talked about the CBOR data here, for example. We verify both the bytecode plus this part. And if you verify this part, this gives you cryptographical guarantees that what you are seeing is exactly what the contract was originally is, because we are basically verifying a hash of the whole compilation, and this gives you higher guarantees. Plus, this CBOR data is actually a IPFS hash, so the whole compilation plus the contracts are available on IPFS. But again, this is not a UX positive, so I would say the UX is the most difficult part for us. So we have other value propositions being decentralized, open source, a different verification. But yeah, in terms of UX, I can't say immediately anything. That's why actually we are trying to push for the parallel verification, because we can't obviously step ahead of the UX. So at least we say, okay, if we can't stop them use Etherscan, let's at least have it verified everywhere. Yes, please.
So, since you mentioned that you know Etherscan, their team, have you talked to them about it? So, what was their response? Did they laugh at it? Did they sound like worried? Like, can you share more about it?
Yeah, no, they're really nice people, as I said, and I talked about this openly many times, and so as I said, Etherscan people are different than Etherscan as an entity and a company, right? So the company is obviously not incentivized to do this, but I would say people, if I put it correctly, people are aligned with this. But of course, they give vague answers. They don't tell me anything concretely. But my general sense is that yes, these people want this to happen. What is that? It's opening up the data, but the company is of course not incentivized to do that. So someone has to push them in this direction.
So where is this database?
It is not decentralized, I'm sorry. It is on cloud, it's on Google Cloud right now. It's a PostgreSQL database working on Google because, coordinating on this is already quite difficult, but I think it's a good enough compromise as long as we do the regular dumps and we share all the data. Maybe in the future we can work on the more decentralization aspect. If you have other ideas without compromising with decentralization, I'm happy to hear.
Yeah, just from my understanding, you mentioned that if a new chain wants to create like this Etherscan on their chain, it costs them, did you say $1 million?
there was a discussion about this on Twitter. I'm just speculating, but they were saying so that's the main business model of Etherscan is Explorer as a service, and since everyone is familiar with the Etherscan, people just want Etherscan, and you have to give them money for the Etherscan instance. Recently, Gnosis actually also do that. For example, like Gnosis main block explorer was Block Scout, but everyone wants Etherscan, so now we have Gnosis Scan as well. So yeah, that's the main business model. Block Scout also has the same business model, but Block Scout is open source, so you can run your own Block Scout if you want to. But you can also go to Block Scout and tell them, okay, can you run a Block Scout for us? And they will do it. I don't know for how much, but I suppose for much less.
I don't know why I thought Etherscan would be open source. Yeah.
That's the problem now. So like the whole ecosystem is built on top of these values being open source and decentralized, and it's closed source and the data is closed.
Do you have a so-called budget strategy for the infra code?
Border strategy,
Budget,
budget strategy.
yeah, for the infra cost.
Yeah, the general idea right now the costs are quite low, like not so high because the database is small and we don't have public access. But the idea is to share among the data providers. So this we don't have a business model or anything. The idea is just to keep this as a public good, let's say.
Yeah, I'm just thinking about because like maintaining public production grade database that for the globally accessible and like for the over the 100 evening chains would cost that's a bit in the end.
Yeah, so the main cost of verification is borne by the verifiers, let's say, Sourcify, Block Scout. We are doing the main work of verification, and we are just writing to the database. That's nothing big. But that's why I had a question mark here, API app access. Like, we might think about giving API and app access, but as you said, it's not an easy endeavor. So the first step is have the public access and regular database dumps, and then we can see how much of the public access we can manage. Any other questions? Okay, then thanks again. And as I said, if you want to learn more, just join these channels or just approach me around Meetup. Thank you.